This is software Staad Flow V8i. Okay, open this one. In that, in this dialog box, we are having a number of options. One is new project, open project. Okay, we are going to start with the new projects. That's why I'm going to select this one. In this, after selecting this one, we'll get another dialog box. In that, we have space, plane, floor. Is option is there. The space in the sense three directions we required, and the plane in the sense x and y direction. So that's why I'm going to select plane, because we are going to analyze the simply supported member or continuous beam. That's why I'm going to select plane structures. Then below that, length is in units and force is in force units and length units are there. Okay, I'm going to select meter and kilonewton. Loads are coming taken as kilonewton, and length is represented in meter. That's why I'm going to select meter and kilonewton. Then click on next. Then this is asking already exists like that. Okay, then click on this and add beams. We are going to adding the number of beams. No, that's why one end of the member is connected with another end, so that's why we are going to add the beam. So click on add beam, then click on finish. Then this, after getting this, the software is open. In free space we are going to close the snap mode. We are not required snap mode. Then another way we are going to represent the nodes. That's why I'm going to close it. Okay, here the right hand side is structure nodes. Okay, then this represents the nodes. Okay, first node is I'm going to start with the origin. Okay, then this software is running with a coordinate system x comma y comma z, like that. Okay, first origin point is having 0 comma 0 comma 0. So next I'm going to select 0, enter, enter. Okay, then next node. Okay, then first node is created here, so that's why. The second node is I'm going to consider a beam like this. Okay, simply supported continuous member. Okay, this is A, this is B joint, this is C joint. So AB member, BC member, I'm going to consider two members. Okay, AB member is subjected to uniformly distributed load of magnitude 20 kilonewton per meter. Okay, then length of the AB member is considered 5 meter. Okay, so similarly, then for BC member I am going to consider our BC member is subjected to concentrated point load at the center of the BC member. So magnitude of the concentrated load is I am going to select 50 kilonewton. Okay, the loads are in kilonewton and uniformly distributed load in kilonewton per meter, and concentrated load is acting, length of the BC member is considered as 6 meter. I mean B to D is 3 meter, and similarly D to C is 3 meter. I mean the concentrated load is acting at the center of the BC member at a distance of 3 meter from the C end, or at a distance of 3 meter from the B end. Okay, we are going to analyze this condition. So that's why this is the XY coordinate for A joint is having coordinates 0 comma 0. Okay, this is the one node. Okay, then this is the first node. Then B node is having 5 comma 0. Okay, then 5, x is moving along. This is the x direction, this is y direction. We not need of y direction value, so that's why the first A node is having 0 comma 0 and B node is having 5 comma 0. Then similarly C node is having 5 plus 6, 11 comma 0. Okay, so this is the condition. So that's why we are defining the values in the software like this. I mean in structure nodes I'm going to create it. The first node is 0 comma 0, then second node is we define 5 comma 0. So 5, enter, 0, enter, enter. Okay, then Z is not required because we are representing the plane structures. That's why only we are x and y coordinates only considered. So third one is 11 comma 0. So 11, enter, 0 will come, enter. Okay, enter. So we created 3 nodes, first node, second node, third node. Then click on this screen, left screen or drawing screen. So here we have number of options is there. Okay, then whatever we required I am going to just consider that one. So first one is here this is a view from Z axis. This is view from minus Z direction. This yellow color is indicating the front, back. Okay, then side, view of side x axis or view of plus x, this is minus x, this is view of plus y, this is view of minus y, this is the isometric view. So I am going to select the front view. So this is a front view, the nodes are coming like this. Suppose you consider the isometric view, then we represent in diagonal direction. So we required, so like this is a front elevation, so front view. Okay, so after considering this, okay, zoom in or zoom out like this. By scrolling the mouse, we'll get zoom in and zoom out. So next we have to add, these are the nodes, this is the A joint, this is B joint, this is C joint we considered. So here by adding by selecting, this is the add beams, we have to add the beams by clicking on this. Okay, after selecting that node point, so join the beams by selecting this. Okay, then click on this, then add, first member is created. So similarly B to C member you have to create, so like this. Okay, then click on escape. Alright, this is the A, B, C. So then we have to, this is comes under geometry. See, this is left hand side set of geometry, general, analysis, design. In geometry we are having beams, plates, surface. Okay, we are considering the beams here, so that's why we are consider the beams, right? Plate in the sense slabs and surfaces comes under in the further parts. Okay, only we are considered the continuous beam, that's why we are selecting the beam only. So in geometry, in beams we are adding the number of joints by add beam. Okay, so next come to the general point. Then second, first we are defining number of nodes and number of structural members. Okay, we are adding it and create the structure, or I mean create the skeleton structure. So next we are going to go to the general. In general we are having property, specifications, supports, load and definition, then material. Okay, here first I am going to select the property in the sense material property, not, this is defining material property. This is the dimensions of the beam. Okay, I am going to select the beam, I am considering the beam dimensions throughout uniform cross sections. I am considering cross section of the beam or beam dimensions is 450 into 450 millimeter. Okay, 450 into 450 millimeter I am going to consider. So that's why the in property, okay, clicking on property, this dialog in right hand side we are having one dialog box. In that dialog box, edit option is there, delete option is there, value, section, database, define, material, thickness, everything is there. We have to first define the whatever we required, or we have to define the dimensions of the beam. So that's why I am clicking on that define. Then another dialog box will come. In this whatever type of structure, or circular, rectangular, trapezoidal, I am going to select the rectangle one. So here meter we required in meter, so I am selected in 450 millimeter into 450 millimeter. ZD in the sense width, YD in the sense depth of the beam. So depth of the beam I am going to define 0.45 meter. Similarly ZD is 0.45 meter. Okay, so this is on. Then here material property, so also we can define here only. So we are using the concrete, so I am going to select the concrete. Or suppose you need steel or stainless steel. Okay, we are also selecting. Okay, so first I am going to select the concrete and defining depth and width of the beam. Okay, so after this criteria, after ending this criteria, we are going to click on add. Okay, so the rectangular 0.45 is a concrete material, this comes in this dialog box. So after that close it. Okay, because AB is also 0.45 and BC is also considered 0.45. That's why I am defining. Okay, ಇವಾಗ ನಾನು ಏನು ಮಾಡಿದೆ, ಡಿಫೈನ್ ಮಾಡಿಕೊಂಡೆ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಅಸೈನ್ ದಿ ನೆಕ್ಸ್ಟ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ಅ skeleton structure. We have to provide property here, no? So that's why first I am going to select this beam. Okay, before going to select, I am clicking on escape. Right, before going to select, first this is a node point. We have to select the nodes. Okay, select the structure, skeleton structures. Only we are creating or selecting the nodes here, because this is a node cursor, this is node cursor, this is beam cursor. So I am going to select the beam cursor and select the skeleton structures whatever we created. So after selecting this, so defined material is selected. Okay, then assign to selected beams. Okay, before, no, this is not highlighting assigned to selected beams. After selecting the skeleton structures, okay, this is highlighted. So assign to selected beams, okay, whatever it defined, okay, we have to assign it and assign, select, click on assign to selected beams and assign. So click on yes. This is asking that the assignment method you have chosen is assign to selected beams. Do you want to proceed? So I am going to select a yes. Okay, so this is R1, this is R1. This is R1 indicates the rectangular first property. This is a rectangular first property. So then close it. So next, now come to the next. We are defining the material is properties, and we have to provide support at the A, B, C. No, that's why selecting the support. Clicking on support, then we are getting the dialog box in right hand side. So that's why then again we have to create. In this option edit, create, delete option is there. So I am going to select the create. So we have to create either fixed support or hinged support or ruler support. So I am going to clicking on create. So in this fixed, pinned, but okay, we know that I am going to select a pinned because this is simply supported continuous beam. So simply supported, so pinned. Okay, then add. Okay, then support 2 is our pinned support or simply support. So after selecting this one, okay, support 2 is selecting, then you have to assign to the this is a node cursor. So you have to select the node. That's why A, B, C joints you have to select. That's why I am going to select the nodes. Okay, then A node, B node, C node. Okay, then support 2 is going to provide or assign to the A, B, C nodes. So as after selecting this skeleton structure, the assign to selected nodes is highlighting. So click on this assign to selected nodes and click on assign, then asking that is do you want to proceed. So click on yes. Then this is the simply supported beam. This is having R1 property, this is having R1 property. So we are defining or we are creating the skeleton structure or the structure of the continuous beam. So we have to assign the loads now. So we are considered 20 kilonewton per meter UDL for AB member. Okay, then similarly for BC member, simply concentrated point load acting at the center of the BC member at a distance of 3 meter from the B joint. So right here load define first we ನಾವೇನು ಮಾಡಿದ್ವಿ ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ಹೋದ್ವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಸಪೋರ್ಟ್ಸ್ ಹೋದ್ವಿ. ನೆಕ್ಸ್ಟು ನಾವು ಲೋಡ್ ಕಂಡೀಷನ್ಸ್ ತೊಗೊತಾ ಇದ್ದೀನಿ. ಇನ್ ಲೋಡ್ ಕಂಡೀಷನ್ಸ್ ಆಫ್ಟರ್ ಕ್ಲಿಕಿಂಗ್ ಆನ್ ಲೋಡ್ ಆ್ಯಂಡ್ ಡೆಫಿನೇಷನ್ಸ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ದಿ another dialog box in the right hand side. So first define in define vehicle definition, the time history, these are the seismic analysis. So that's why we are not required that one. So only load cases and details I am clicking on this and add, click on add. Okay, here it is asking primary load generation. We are first primary definition or primary defining the conditions. Okay, first load case is dead load. Okay, we have to assign the dead load. So dead load, I am going to represent the dead load. So next here none loading type is, this is dead load, no? So loading type is dead load. Then also title of the, we are only title is for us. Okay, this is representing for, this is a dead load, this is a live load, like that. So this is the title is dead load, but we are defining the dead load here. So click on add. Okay, similarly we are going to define live loads also. So two live loads are there. These are the dead loads is comes from the cross sectional dimensions. So then live loads is coming from the UDL and point load. Okay, we define dead load, and next condition load case 2. Load case 2 is live load, so that's why I am LL. I giving the title LL, and here also load type is live load. Okay, I am going to select the live load. Number of loading conditions is a dead load, live load, roof load, wind load, seismic load. Number of cases are there, so I am going to select the live load for second case. I mean in the sense after selecting all these conditions, defining all this, then click on add. Okay, then here in right hand side see dead load, first case dead load and second case is live load. And also we are having two live loads. One is 20 kilonewton per meter is a UDL load, and 50 kilonewton load is there. So that's why another third condition I am going to also, the load case 3 is also live load I am going to select. Then it is also a live load. Then here click on add. Okay, this dead load is a different thing, and live loads are UDL, 20 kN per meter is the one live load, and 50 kN is the another point load. These two are the live loads, so that's why we are going to select the load case 2 as a live load, load case 3 as a live load. Okay, so then close it. After defining the number of load types, then I am going to close this dialog box. Then we have to assign, we are defining the loads conditions. Okay, the next step is going to assign the dead loads, live loads. Okay, then dead load for whole structures, I am going to select the whole structures, and dead load, I am going to select the dead load and add. Okay, first before going to define, only we are defining dead load, whatever the conditions of dead load, so we have to select add. Then another dialog box will come. This is the self weight of the load. Okay, then nodal load, member load, and physical member loads. Number of loading cases are there. First we have to only defining load, self weight of the that is member, self weight of the member. So that's why that load is acting in a y direction, in a vertical direction, in negative manner. That's why factor we are going to select in a -1. Okay, then x, y, z directions are there. Okay, so we are selecting only y direction because the load is acting in a downward direction in a negative manner. That's why y -1. Then add, click on add. Then here see in right hand side the self weight in y -1, y direction. Okay, so that is a dead load condition. Before going to assign, this red question mark will come. Okay, after assigning that we'll see. Okay, then what are the colors will come, right? Then next come to the live load. Okay, close it and come to the live load. Okay, add, click on add. Another same dialog box will come, but live load is, first live load condition is considered for uniformly distributed load of magnitude 20 kN per meter. So that's why we are considering not a self weight, we are considering the member load. Click on member load. Then again uniform force, uniform moment, and concentrated force, concentrated moment will come. So we are assigning uniformly distributed load. Okay, so here uniform force is there, so that is a uniform force. Okay, uniform moment is different, and uniform force is a different, and concentrated force is a different. So that's why uniform force we are going to assign uniform distributed load, in the sense uniform force. So right, then what is the magnitude of uniform force? 20 kN per meter. So that's why 20 kN per meter. So then here in the, see the picture, the D1 is the one end of the starting point of the uniformly distributed load, and D2 is the end point of the distributed load, and D3 is the starting point of the node, in the sense A joint. Okay, you can consider, so A joint is the D3 and B joint is our D2, because the throughout span is having uniform distributed load. That's why I am going to select. So we can select the 0, 0, 0. Then that is also a uniformly distributed load is acting throughout the member. Okay, so we can select GY direction. Okay, then suppose you can, if any wrong in these conditions for defining, we can edit it also by using this option. In right hand side we have edit option is there, so you can also edit it. So D1 is 0, okay, and D2 is 0, then D3 is 0, in the sense this is load is acting throughout the structure. Or suppose we are considering D3 is 0 and D2 is 5 meter, we can also defining that. Okay, add it, then close. This is the uniform distributed load in the y direction at a magnitude of 20 kN per meter of 0 to 5 kN, in the sense 0 to 5 meter. Okay, that is the length. This is first direction, it is indicating first direction in the y direction, and this is gravity load, then that is live load at the 20 kN per meter at a distance of 0 to 5 meter length. Okay, so next again click on live load, because we are going to define 50 kN load, no, that's why that is also a live load. Then click on live load and click on add, and then again it is member load. Okay, not a self weight, not a nodal load. Nodal load in the sense the force or moment is acting at a particular joint. That's why you are at that point you are going to define nodal load. But here member load is there, so that's why that is a concentrated force we are going to define. What is the value of concentrated load? That is 50 kilonewton. That is P is equals to 50 kilonewton. Okay, then this is in a y direction. So then 0 to 3 meter. Okay, D1 is our point load acting, okay, below the point load, and D2 is our end of the member, or consider any end of the member. So D2 is we are representing D1 is our D, then D2 is our B joint, so 3 meter. Okay, D1 is 0 and D2 is, I am going to represent 3 meter. Okay, 3 meter. Okay, the dimensions or units in meter. So click on add, close it. Okay, right here load, and this is a very important load cases detailing. So first we are we are defining what are the load conditions are there for us. One is dead load, another one, two live loads are there, so we are defining dead load, one live load, another one live load. Okay, so here dead load is we are defining, that is a self weight. Okay, then right, then for live load, one is a UDL, another one is a point load. So we have to assign for this particular members. So that's why click on this self weight, okay, and select the structure. Okay, first you select the structure and what are the loads we are going to assign, self weight. Okay, right here after selecting these two, the assign to selected beam is highlighting. Okay, click on this. Okay, assign to selected beam is not highlighted. So first I am going to select the beam. Next, self weight. Self weight is throughout member is same, right? That's why I am going to select whole structure and select a self weight and click on assign to selected beams. We are selected beam, ಅದಕ್ಕೆ assign ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ select ಮಾಡಿಬಿಟ್ಟು click on assign, then click on yes. Load 1 is assigned already. Okay, so load 1 here, load 1 case is coming for this. Okay, then after selecting this, then this is a question mark here. We are not assigning any assigning to any beam or any member. Okay, that's why this is a question mark is the only that indicates or that telling us this is not assigned like that. Okay, so this is assigned already. So next select we are uniformly distributed load is acting from A to B, no, so that's why I am selecting only A to B member. Okay, then click on this. This is a 20 kilonewton per meter. Okay, this is 20 kilonewton per meter. This is UDL, we are defined already, but this UDL is assigning to AB member only. That's why this is a AB member. I am going to select this one and click on selecting the assign to selected beams and click on assign and yes. So this is GY direction. This is uniformly distributed load is acting in upward direction. Okay, so one second. Okay, Control Z. So we can edit it. Edit option is that 20 kilonewton load GY. Okay, change it. Sorry. Okay, one second. We are changing here minus 20 kilonewton. Edit again. Edit. This is we are going to give minus 20. So that is a Y direction, but this is not a minus GY, but self weight is defining for minus GY, no. So here this is not giving a minus GY, sorry for that. Okay, then first W1 is we are going to assign, that is minus 20. So minus 20, 0 to 5. So change it and close it. Okay, we comes in negative direction. Okay, that is in GY in the sense it is a vertical direction, but it is not minus GY. So that's why we are in defining time ನಾವು ಯಾವ ಡಿಫೈನ್ ಮಾಡ್ಕೊತಿರ್ತೀವಲ್ಲ ಆ ಟೈಮಲ್ಲೇ ನಾವು minus 20 ಅಂತ ಕೊಡಬೇಕು. So sorry for that. Again we can edit it. Okay, so edit, let's click on, because 50 kilonewton load is a minus 50 we are going to define, no, that's why edit it and minus, provide minus 50. So minus 50. So GY, change it and close it. Okay, so next again assign or select, first select this member and select this one and assign to selected beams, assign, yes. Okay, point load is acting here. Okay, one second. So this is definition is 0 to 3 meter. Edit, D1 is 3. Okay, you can change it. 0, we can change it 3. Okay, change, close. Okay, then point load is acting at the center. Okay, 0 to 3. Okay, once again I will show you this one. Okay, right here D1 is D2 is a 0 and D1 is a 3 meter. Okay, so like this defining. Okay, change it, close it. Okay, after assigning load 1, load 2. Okay, selecting this one, load 1 is show, and select this one, uniformly distributed load is showing, and load 3, this is a point load acting at the center. Okay, right, once again I will show everything. Okay, the edit option, then here only Y, a factor minus 1, that is okay. Then but uniformly distributed load, okay, you can will show, then minus 20 we have to provide, and distance is here D3 is our 0 and D2 is our 5 meter, in the sense total from D3 to d2, up to d2 in the sense 5 meter, so 0 to 5 like that. Okay, then y direction minus 20 is indicating negative direction force, that right, close. Next, similarly this one also edit option, so this is a 0 and this is 3 meter. Okay, like this you have to provide, right, minus 50. So next, this first property we defined, and support is assigning, and load and definition is load defined and assigned also. Then material in the sense concrete already selected. So next come to the analysis and print part. Okay, we are geometry, defining the geometry, or then general conditions we are also did, but analysis and print. Okay, first you have to analyze. Analysis in the conditions, in this condition you click on all, perform analysis, click on all, add it and close it, and here then perform analysis on print all, and here click on this and assign. So right, right here analysis in part, in this analysis part, analysis print, analysis here in top commands are there, then analyze. Okay, go to analyze, and this is asking auto save option, so that's giving a save option. So go to analyze and run analysis. Okay, giving this, then this is going to analysis, then go to post processing, view output file. After analyzing, this is asking view output file, go to post processing mode and stay in modeling mode. Okay, so this is go to post processing mode, select post processing mode, in the sense it will give the values. Okay, so done, right, this is apply. Okay, so this will give the results. Okay, for node conditions, what are the node will coming, and beams. Okay, this is the bending moment. Okay, then here see, this is fx value, fy value, fz values will give. Okay, these are the fx, fy, fr are the shear forces in x, y, z directions, and mx, my, mz are the bending moment in x, y, z directions. Okay, so these are the deflection values, gives a deflection value, displacement in the sense displacement. So right, come we are seeing values like this. Okay, fx, what will happen, axial loads in the load case 3. Okay, you select load case 3, load case 2. Okay, like this. Okay, envelope in the sense 0 load will come. For dead load, what will happen for fx? Okay, next, then what will happen for fy? For dead load. Okay, for z direction. Okay, so you can also dead load plus live load plus live load. Okay, live load 1, live load 2, we can also do like that. Okay, then come to again we can go back to the mode, animation beam. Okay, once again. Okay, the modeling mode, modeling, we can go to the modeling and again analyze, run analysis. Okay, the go to post processing mode, done. It will asking some question like that. One second, again go to modeling mode. Load envelope is there. Okay, then go to general and load envelope, and we have defined load like this, and load envelope is there. Okay, add here, then dead load plus live load plus live load. Okay, so select all these conditions. Okay, so add it, and yes, stress serviceability column connections for strength. Okay, okay, leave it. Okay, then go to the building modeling, in the sense analyze, run analysis, go to post processing mode, done. Okay, it will give like this. Envelope load cases is selected list, envelope 1. Okay, range results option, loads. Okay, then select all these loads and shift to this side and apply, and okay, then here, so load will come like this, and moment, what will be the bending moment will occur, and beams. Okay, go to the beam, bending moment for in z direction, bending moment in y direction. Okay, we are always consider the moment in z direction, that's why the moment will come like this. Then for shear force, okay, for shear force, annihilating this one, fx, okay, fy, okay, fy, then fz. Okay, we already always we are considering the y direction force, fy, but MZ we considering. Okay, right here these are the results like this. Animations we not required. Okay, then reports, we required reports, right? Beams, okay, material like that. Okay, it gives the report like this. Right, these are the report. Whatever you required in a report, you select loading generation, loading conditions, okay, the support conditions, releases, okay, basic load cases, combination of load cases. You select all these and click on OK, right hand side, and OK, select. Okay, it will come everything. Okay, rectangular beam you provided. Okay, 0.45 into 0.45, area, IYY, IZZ, Z value, material. Okay, everything is given. Node A is having one node, first node, second node is B. Okay, right, like this. Length is 5 meter, 6 meter, properties 1. Okay, these are the values. Stress, so stress, stainless steel columns, these are the materials, E values and alpha values it will give. Okay, right, reports. Close it and go to the modeling mode. Okay, this is the conditions. Okay, right,